Today our topic is to learn about functions, right? It's a PO3 mathematics. Today we are going to learn about functions, right? We have learned some kinds based with these functions in our GCSE classes as well. So what do you mean by a function? What is a function? Yeah, that's the first answer where we should face before you learn about these ones. The simple idea about function is it's a relationship between input values to output values. So like, so due to like, we know that some input values and some like the values you input, from that you get some kind of outputs over there. So depends on the input, the output might be changed. The relationship which shows the what do you call the interconnection between the input values and output values are called the function. So a simple idea of a function is the function is a relationship between input values. Input values. In mathematics, we use a term called input value. Hereafter, we won't say the term input values. We call them as domain. Domain and output values. And output values. In this one is we just call them in different term. Here we won't measure as output values. We call codomain or we call range. But in our curriculum, we prominently use the term range, not codomain, right? So, but both terms, there's a slight difference between codomain and a range, but we use the term range in our stuff. For example, if you get, we will get some, the relationship is we represent by fx. Fx equals to 3x. Now we get kind of input values. We say this, the input values are -2, 1 and 3. These are the input values available. Then what would be the output values? Output values, if you put -2, answer is -6. If I put 1, it's 3. If I put 3, it's 9. So you can find the relationship between these two. That is the simple idea about a function. Right. So we should know this first property when you're learning about a function, right? The second one. So in this case, there's a one more thing we need to understand about this function. That is, if I ask a question like this, do all relationships become a function? Yeah. So if you consider all of these relationships, there cannot be a function. The simple answer is no. Then you can see only the relationship which satisfy two main conditions only become a function. Only again only the become a function. Become a function. Right? Okay. Now let's see what are the properties where a function should satisfy to become a function. What are they? The problem is, what are they? The first property is, answer is, what are they? Right. The first property is, the function, rather than writing a function, you can, the relationship. The relationship must obtain a value in domain, in range for all values in domain. That means, Pute, if you mention whatever the figure value in domain, there must be a solution in codomain, or there must be a value in range. Can I? For all input values, there must be a output value. I write from simple words, that is for your convenience. All input must gain an output value. That means this is just like, that whatever the relationship, this is a common fact. So unless you have an answer for all input values, all the answer, all the questions, there should be some kind of output answer for this. Are there any situations which is exception from this, and which is not falling to the functional category? That's a fact where we need to understand next. That means, for example, like this, they have given a function like this, fx. It's a relationship. I cannot write it as a function. It's 1 over x. Then they mention x is any real number. This notation is what? X is any real number. If I write it from a different color, just to understand, x is any real number. What are the real numbers? 1, 2, 3, 4, -5, -6, -7, 0, half, 1 over 3, 1 minus half, -1 over 3, -5 over 3, like that, whatever all the values come under the real answers. Now you can see whether this is a function. That's a factor to understand. Now they have given the domain. What is the domain over here? Domain is any real number. Then for any whatever the real number, does this relationship has a solution? Answer is, you can say, if x is equals to 0, fx is 1 over 0 does not exist. Does not exist. Does not exist. Therefore, fx is not a function. Fx is not a function, right? That's a factor to understand. But if they have given in this way, they might give you a function like this, gx is 1 over x, and they might give a question like this, x is any real number and x is greater than 2, right? So for this domain, what you can understand is, like when you put these input values for more than 2, input values more than 2, you can see whatever the value you replace more than 2, the answer, there is an answer for this 1 over x. There is no other restrictions for this. So you can say it's a function. Yeah, it's a function. So you can say it's a, no, we cannot say it's a function, because we need to see whether it satisfies the second condition as well. It satisfies the first condition. Satisfy the first condition. First condition, what you need to understand is, like to say it's not a function, violation of one condition is enough. If a one condition violates even, you can say it's not a function. But to show it's a function, we have to show that both satisfy the situation. So in this case, we don't know whether it satisfies the second situation. So for the moment, we can write it as satisfy the first condition only. That's a factor to understand. Right, okay. Let's go ahead a little bit further. Right, let's go ahead with this. They might give you hx. Hx is square root of x. X is any real number. This is a function. Now you can see, if I replace -1, what you can say? H minus 1, what would be the answer? It's not a real number. So you can say not exist. Therefore, hx is not a function. This is pretty simple. To show it's not a function, it's very easy. Showing one example where it violates the condition, it's enough to show it's not, right? But if you want to show it's a some kind of like it's a function towards foreside, you need to show all the required condition, which we have to show that there is none of the conditions violate the situation. If a single condition violates even, we can say it's not satisfying the given condition. Right? Okay, that's how we have to do it. Right? Okay, we'll get this one. This mx is square root of x. They have given x is any real number and x is greater than 0. If x is greater than 0, not a problem. For whatever the value you replace over here, it satisfies the first condition. So you can say satisfy the first condition. Satisfies the first condition. That is a fact we need to understand, right? If I repeat it, to show it's not, one violated condition is enough to show it's not. To show it is, we need to show all the conditions which satisfy that fact, right? Okay. Then we'll come up with the second condition. The first condition we already explained from these examples. Yeah, the first condition. The second condition is this just like this. Second condition is one domain figure. One domain figure must obtain only one answer in range. But remember, you have to memorize this, but the opposite is not required. Not required. Right. Let's see what is this condition, what this stands for. For example, like this, we get the function fx is equals to like this square root of x, where x is greater than 0, right? Then look at this. If I sketch this graph, look at this, just if it is a situation like this, you get x values, input values. We'll get 4 and 9 just from two examples I show you. What are the y answers? So if I get two x answers, these ones and the y answers, the square root of 4 is how much? Plus 2, minus 2, plus 3 and minus 3. So in this case, what you can say, for x, you get for one x answer, you get two solutions. But here, look at this. That means if I plot this graph and if I show you even, what you get with it? The square root x graph, if you just draw it, it's just like this with it. If I get one x answer 4, you get two y answers. Plus 2 and minus 2. If I get 9, it's, look at this, it's plus 3 and minus 3. This is not possible with it. You cannot say like this. So one person, for example, yeah. So the person, so like this is not a function. So it's not a function. Not a function. That means here the person is this side. Their birthday is into other side. Just like this. Birthday. Like this is Kamal and John. Kamal and John. Can it be like this? 2006 and 4 and 2003, 8 and 2. Is it possible or not possible? One person, can they get two birthdays? Yeah, so obviously we know that it cannot happen, right? So obviously it's not. Yes, that's great. Yeah, it's not possible for this particular, right? Okay. Then this is fine. Then this is 2003 and 2 and 1. So in this case, nothing to worry. So over here, because this condition violates, that it's not possible for this situation, put it right. But the opposite cannot be. It's opposite. Opposite is possible. This is person and birthday. This, that is John and Alex. Alex, John's and this one. So you can say 1999, 3, 4. This is possible. John and Anne both can have the same birthday, whereas Alex is having 2006 too. This is possible. It's not a problem for a function. What kind of situations we are discussing about? One x value can obtain two x values can obtain one y answer, but one x value cannot obtain two y answers. That's a factor to understand with this. For example, we'll get y equals to x squared. Now look at this, Pute. If I get y equals to x squared, what you can say? Like this. It's x squared graph is like this. So, if I get like this, maybe plus 2 and minus 2, both having the same y answer. It's possible, but one y answer cannot obtain two x answers. One x answer cannot obtain two y answers, but one but the other opposite of it, but the one y answer can obtain two x answers. That is the fact you can get it. So I just and make it 1y, 1y, 2x. This is not possible. This is wrong. But uh, sorry, this is possible. I just made a mistake. Just like this, 1y can obtain 2x answers, not a problem, but 1x cannot obtain 2y answers. This is not possible. That is the point to understand, right? Okay. So right, that is factor to understand with the function. So if they satisfy both of these conditions, we can say it's not a function. It's a function. If a one condition violates even, we can say it's not a function. I'll get another example for this, but just like this. Okay, gx is this like this. They are given as a graph. Now tell me whether this is a function or not a function. Now you can see if I get this x answer, you get two y answers. Two y answers. So this is not a function because what is the reason, Pute? 1x gain 2 y values. That is not a function at all. Then, Pute. That's the factor to understand with this kind of situations, right? Okay. So that is the main things where we need to understand about function. So we'll go ahead with another example. We'll see. You have given the function fx is equals to x plus 2. They have given x is any real number. We need to see whether it's a function or not a function. So we'll draw this and see. So it's a straight line over here. 2 and this is minus 2 if we just draw it perfectly. X and y. Now you can see whether it satisfies the first condition. Whatever the x value you replace it, you get a y answer. Not a problem at all here. To the negative side or positive side, it's not a problem. One x gain only one y answer. It's not a problem. It's a function. So I can say it is a function. It is a function. Yeah, right. It's not an issue at all, right? We'll go ahead with another example. You get another thing, gx. It's just like this. Say x cube. Yes, x cube graph is just like this. Now tell me your opinion whether it's a function or not a function. Pasidhu just put in the chat, and Amelia just put in the chat whether
It,
the function. Okay, you can just tell, even doesn't matter. Is it a function or not a function?
function, sir.
It's a function. Amelia, what is your opinion on that? Yes. Yeah, it's a function. That's great. Okay. What is the reason? Because you can see all the x values from this side, it can go up and up and up, down over here. So it's a function. So it's a function. It is a function, right? Okay. Now, yeah, this one. Let's go ahead with another one. Hx is they have given. I'll just draw the graph initially. Later on, we learn how to draw these graphs. X plus 2. So the graph is just like this. Later on, I'll help you how to I will teach you how to draw these graphs. Now tell me, is this a function or not a function? Pasindu, what is your opinion on this? And Amelia, what is your idea on this?
So function?
Your opinion is function. Yes. Yes. Amelia also tell it's a function. Then put just substitute 2 and see whether what is the answer for this question. Sorry, minus 2. Replace minus 2 and see whether what is the answer you obtain if I put minus 2. At minus 2, can you find an answer for this? Yes or no?
No, sir. Can't.
No, it's not nice because you can say it's not a function. What is the reason? Because that if I put minus 2, its axis of asymptote comes over here. Therefore, it's not a function. So you can say at x equals to minus 2, hx does not exist. Does not exist. Therefore, hx is not a function. Okay, that's a simple way of reading this. Then what is your opinion on this? They have given a question like this. Hx equals to 1 over x plus 2, and they might give you the question like this. X is any real number and x is greater than 2. That means from this graph, it's only this bit is there. From here only it's there, because they are referring to the graph over here. Now tell me, is this a function or not a function?
Function, sir.
It's a function. Yeah, Amelia, what is your opinion on this matter? Yes. Okay. Yeah, now it's a function. What is the reason for that? Because more than x equals to more than 2, whatever the value you replace, you can find a 1y answer. Doesn't make a sense on that, right? But and one x answer is having only one y answer. So you can say it's a function. So in this case, you need to be very careful with this. We have to see whether with the exist sometimes the same question with the different kind of domain, it might be a function and sometimes it might not be a function, just like this. Then this tell me, just like we get gx is equals to square root of x plus 3, right? Now if I sketch this graph it's a graph like this. X is any real number, right? Now, what is your opinion on this, Pute? Right. Then, now look at this. There are actually for this graph now we can say a lot of situations to violate this is a function. The first condition is if I replace a value less than minus 3, because if the domain is any real number, therefore whatever the value for the minus side and positive side, we should be able to replace. If I put minus 4, what you can say, Pute? The function exists or does not exist? It's not exist, right? So therefore it's not a function. So you can say if x is less than minus 3, gx does not exist. Therefore, gx is not a function. Gx is not a function, right? Okay. There's a second fact just like this. Mx is equals to square root of x plus 3, and they have given x is any real number and x is greater than minus 3. Now tell me whether it's a function or not a function. Therefore, the x coordinate is only here. It's not, it's ended up from here. Just one sec. It's only minus 3, up to minus 3, only the graph is there. It's minus 3, right? Now tell me, what is your opinion on this? It's a function or not a function? Passing to opinion is it's a function. Amelia, what is your opinion on this matter? Let me see. It's not a function. Why? Because you can say, passing to this is the point to understand. It satisfies the first condition. For more than minus 3, it satisfies. That is correct, but you can see this x coordinate. For example, x equals to 1. Then what is that answer? X equals to 1 means 4. Square root of 4 is how much? Plus 2 and minus 2. So for 1y answer, it's having only one x answer is having 2y answers. Is this a possible situation for a function or not a possible situation? It's not possible. So you can say for one domain value, there are two range values are there. Values exist. Therefore, it's not a function. It's not a function, right? Okay. Then let's go ahead with this. They have given this way. Nx is, they have given x plus 3. They have given the positive root. That is specifically they mentioned we are concerning about the positive root, not the negative root. X is greater than minus 3. That means the graph is just like this. Yeah, this is y, sorry, and this is x. Now tell me whether this is a function or not a function. Yes, Pasin, what is your opinion now? Now it's a function, right? Okay. Amelia, what is your opinion on this now? Yeah, it's a function. Yes. So the reason is that for more than minus 3, whatever the value you substitute, you get an answer. And one x answer is having only one y answer. Therefore, it's a function. It is a function. So those are the basic concepts we have to understand about a function. So we should know these properties when you are discussing about a function, and we should know how to find whether it's a function or not. So that is the main concepts we have to learn as a basic properties of a